The voltage regulator is one of the indispensable circuit components of electronic products and is used on many electronic cards. The voltage regulator has 3 pins. The first pin represents the input, the second pin represents the ground, and the third pin represents the output. The main task of the voltage regulator is to convert a DC voltage within a certain range at the input end to a constant voltage at the output end. So how does it work? Let's start with the working principle of the LM78 series voltage regulator. According to an example, when a DC voltage of 6 to 35 volts is applied to the input of the 7805 voltage regulator, the value of the output voltage is constant at 5 volts. If the output value fluctuates by 5 volts, the main role of the capacitor here is to make the output voltage value in the circuit constant. The fluctuation value of the output voltage of 5 volts is eliminated thanks to the capacitor connected here. It also provides a smooth DC voltage so that the current filtering is completed. We can show the relevant working logic in a graphical way. For example, input a DC voltage of 25 volts. Due to the voltage regulator, this voltage is provided as a constant 5 volts at the output end. We are using a 7809 voltage regulator here, which can provide an input voltage of 10 volts to 35 volts at a constant output of 9 volts. Here we use a 7812 voltage regulator, which can provide an input voltage of 12 volts at the output end at a DC input voltage of 3 to 35 volts. Let's do a simple circuit application experiment, showing the electronic circuit diagram in the diagram state. When a 12-volt power supply is connected to the input of the voltage regulator, that is, to the first and second pins, we can get the output of the 7805 voltage regulator between the third and second pins, and the output voltage is 5 volts. The 330 ohm resistor in this voltage regulator will light up the LED lamp in this way. To make this situation more visual, we can create a circuit as a demonstration. The circuit includes a 12-volt power supply, a 7805 voltage regulator, a 330 ohm resistor, and an LED lamp, which reduces the 12-volt voltage at the input end to a 5-volt voltage at the output end. Under the action of the 330 ohm resistor, the LED lamp can emit light at a voltage of 5 volts. If a 7809 voltage regulator is used, the original resistor must be replaced with a 470 ohm resistor so that the output voltage of the resistor is 9 volts. Now let's see what the letters and numbers on the resistors mean. This part shows the relevant data of the voltage regulator, and that part shows the output voltage value. For example, the output voltage of the LM7805 voltage regulator can provide a voltage of 5 volts and a current of up to 0.5 A. The output voltage of the L78S05 voltage regulator is still 5 volts, and it can provide a current of up to 2A. In other words, the output voltage of these voltage regulators is fixed at 5 volts, but the current value they can withstand without cracking is different. For example, the output voltage of the LM7809 voltage regulator is 9 volts, and the maximum current value it can withstand is 0.5 A. It should be noted here that the voltage value can be fixed, but the current value will change according to the resistance value of the load connected to the output. In other words, the current value will not be fixed, and we need to choose the voltage regulator according to the maximum current value in the circuit. Voltage regulators are generally not installed in high current circuits and are generally used in electronic cards. If we want to stabilize the voltage converter by stepping down the voltage in a circuit with a large amount of current, we need to use a DC-DC buck converter. As can be seen from the picture and circuit structure, a voltage regulator that generates a negative voltage is also required. Negative voltage regulators start with 79, not 78. Using the 7905 voltage regulator, we can get a constant -5 volt voltage at the output. Similarly, we can use the 7909 voltage regulator to get a constant -9 volt voltage at the output. Their input, output, and ground pin names are different. So in this series of voltage regulators, 1 pin is grounded, 2 pins are input, and 3 pins are output. Pay special attention to this when connecting. Adjustable voltage regulators are also used for voltage stabilization. LM78317 is the most commonly used voltage regulator. Here you can see the circuit diagram using this regulator. The output voltage can be adjusted by the value of the R2 resistor in the circuit by using a potentiometer instead of this resistor. The desired output voltage between 1.5 volts and 37 volts can be obtained at a DC input voltage of 40 volts. There is also an AMS 1117 voltage regulator for electronic circuits, which also has 3 pins. In this voltage regulator, the third pin is the input, the second pin is the output, and the first pin is ground. In this case, the DC input voltage between 6 and 35 volts is fixed at an output value of 3.3 volts. It is widely used in many electronic boards, and a suitable voltage regulator should be selected based on the voltage and current values required by the expected circuit, and the voltage regulator should be selected based on the voltage and current of the expected circuit. The types and working logic of voltage regulators are basically like this. When buying a voltage stabilizer for your home, you need to choose one that meets your home's voltage requirements and is made of pure copper. It is best to buy it from the source factory to ensure the best quality and the lowest price.